Welcome to Ask and Learn.
Alright, so let's solve this engineering mechanics statics problem, and this is a jib crane, right? And we need here it has a load of 780 pound, and we need to find the reactions at these supports, right? So this is point A and this is point B. This distance is 4 feet and this distance is 5 feet, right? And we need to find the reactions. So one reaction it is here, which is NA, which acts at this point, right? So NA, we will need to find this reaction, and here it has two other reactions. So this one is BX, which is in the X direction, right? This is BX reaction, and this is by reactions, right? So we will need to find these three reaction forces here, right? So applying the moment equilibrium equation at point B, right? So applying the moment equilibrium equation at point B, which is summation of all the moments at point B is equal to 0, right? So after applying this equation, we had normal force which is in this direction, right? So in A, right, and the distance is this is 4 meters, 4 feet, right? So this is 4, and minus the weight acts in this direction opposite to this normal force, right? So minus 780 pound, and the distance is 5 feet, right? So this is 5 feet and all these are equal to 0, right? And after calculation, we have found that the normal force in A is equal to 975 pounds, right? So this is the NA reaction force, right? And we also need to find this By reaction force. So applying the force equilibrium equation, so all the forces in the upward direction, all the forces in the upward direction is equal to 0, right? So this has By force which is in opposite direction, upward direction, right? So By and minus 780 pound, which is in the opposite, which is in this direction, uh, to downward direction, right? So this is minus 780 pounds, right, which is equal to 0. So this By reaction force is 7 By reaction force is 780 pounds, right? So this was the By reaction force, right? This is only the weight which is applied here, right? So this is only the weight which is applied here, right? And we need to find this Bx reaction force here, right? So for this Bx force, we need to apply the force equilibrium equation in the x direction. So summation of all the forces in the x direction, right? Summation of all the forces in the x direction is equal to 0, right? So this is force equilibrium equation, right? So in the x direction, we have only this force, right? So we have 975, right? So in the x direction, we have only this normal force, right? This normal force, which acts opposite to this Bx normal force, right? Bx force, right? So after applying the force equilibrium equation at this point, this is 975 minus Bx, right, which is equal to 0. And from this, the Bx reaction force is 975 pounds, right? So this was the third reaction force. So we have found all these three reaction forces here, right?